This is the lesson for Chapter 10, Section 5, and it's titled Reading Scientific Notation Day Number 1. And so what we'll end up saying, again, this is 10.5. And so scientific notation basically is a number written where it represents the product of a factor and a power of 10. So what we have here is an example. This is 8 3/10 times by 10 to the negative 7th. And so this is our factor of this number, and I call it the multiplier. And so it's a multiplier because we're multiplying it by a power of 10, which we have here as 10 to the negative 7th. And so in order to understand scientific notation, we need to understand powers of 10. So powers of 10, if we start off with just 10 to the 0 power, that was 1. That's what we end up seeing in the last section. 10 to the first is just 10. 10 to the second would be 100 because it's 10 times 10. 10 to the third power ends up being 1,000. So a lot of people start to see a rule, and they say, okay, well, if 10 to the third is 1,000, and I see 10 to the fourth is 10,000, I see that if I look at the exponent, that's the same number of zeros in that number. So that would tell me 10 to the seventh would be 10 million. So if I wrote out 7 zeros here, one more zero there, that would end up being that number. Well, that's true. It is the number of zeros because it's a power of 10, but we're going to say the 7 represents the number of place values. Place values. And I'm going to use that because sometimes we don't just have 1 as the first number on the far left-hand side of the value. So another thing we have to look at is negative exponents. So let's say it was 10 to the negative first. It's not a negative number. It represents the reciprocal of positive exponents. So it's 1/10. So it means it's 0.1. And if I had 10 to the negative second, that would be 100th. And that represents 0.01. And then 10 to the negative third, you see that is going to end up being 1,000th, which is 0.001. So these are the types of numbers, and all they do, that power of 10 just moves the decimal point either left or right. And if the exponent's negative, you can see how that exponent is going to the left 3 spaces. If it's a positive exponent, if we start with 1, if we have 10 to the first, it just moves it to the right 1 space. Again, that's why it says exponent positive, move to the right. Exponent negative, move to the left. So again, if I had this as my number, let's say the number was 500 or maybe even 5,000. You see, I can rewrite this number as the factor of 2 values. See, one of the factors is 5. The other factor is 1,000. Those two numbers multiply to make 5,000. That's where they get this from, the product of a factor and a power of 10. Well, the power of 10 I don't see yet, but I could rewrite 1,000 as a power of 10. I could write that as 10 to the third. And what they're going to do is, instead of using the dot for multiplication, because that kind of can look like a decimal point at times, we're just going to use the x for the multiplication. And here's my multiplier. See, 5 times by 1,000, and I'll represent 1,000 as a power of 10, represents this number. Now, it's very useful when the numbers are really big, kind of like this number here. And so we're supposed to specify or tell whether this is written in scientific notation. Now, scientific notation has a certain form, and the form is the multiplier is the standard thing that we need to look at. And here it is. The factor, or this multiplier, is greater than or equal to 1, but less than 10. And so that's what we end up seeing here. So this one is in scientific notation. So I would say yes, because the multiplier, and again, they're calling it the factor, but I'm going to call it the multiplier because it's being multiplied by this power of 10. The multiplier is between 1 and 10. So on this one, this is not in scientific notation. Again, if you look at this multiplier here, we could see that that is 10.5, which is 10 or bigger. And so we'd say, no, the multiplier is greater, or is 10 or greater. And so if that multiplier is greater than 10, that means that it's not in scientific notation. And on this one here, this is less than 10, so this is not in scientific notation. So no, the multiplier is less than 1. So if the multiplier is less than 1 or greater than 10, or 10 or greater, it's not in scientific notation. So let's take a look at some other types of problems that we'll see. So oftentimes when we're dealing in scientific notation, we might be using a calculator to do a big calculation, maybe a multiplication problem of some numbers that make the number so big that it doesn't fit on the screen. And because there's limited space on the screen, they might use scientific notation to represent that. Well, calculators don't use, not all calculators use the times sign. Some of them do now use the X for the times sign, and they'll sometimes instead use this E. And the E basically represents the times by 10 to a power. So this is the same thing as 5.6 times 10 to the power of 12. And so this E just means the exponent is 12 on the power of 10. So if I was to write this out in standard form is just the regular number, you're going to move the decimal 12 spaces to the right, or 12 place values. So you move it one space over to get to the other side of the 6, and then you've got 11 zeros to finish off writing. So we've already dealt with one space there, and so now 11 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then put the commas in, starting from the far right-hand side, and you continue on, and there's our number. So on this one's a small number because it's a negative exponent, so it represents 2.1 times 10 to the negative 10th power. And so I'm going to start moving the decimal one space to the left, and then I've still got to go 9 more spaces. So what I'm going to do is I'm going to count, after this decimal point, 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the 2 and the 1. And that would be that value. This one is a bigger number because it's a positive exponent. So if I was to write this in scientific notation using the format that it is with a power of 10, that would look like this. And so it's got to move over 16 spaces to the right. Well, 2 spaces are taken up with the 7 and the 3. So that means I have to add 14 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then I can get that number. So you can see, especially with this example here, why people use scientific notation, because it takes a long time to write those zeros. It's kind of cumbersome for us to look at them like this because there's so many of them. So the 16 just tells us 16 spaces to the right, 16 place values to the right. So let's take a look at an actual calculator, and some of them do this E to the 12th power, but some of them do something a little different. So let's take a look at this example. And so if I was to take a number maybe like 0.1256 and multiply that by something very small, so maybe 0.0, and I'll add in some zeros here, make that very small, and we'll go with a 9/8. Let's see if that puts it into a scientific notation form. It does. So you can see how that number is showing, instead of the E, they're writing the expression, the numbers that I get, and then once they hit a row of zeros, they're saying it's times 10 to the negative 7th power. And so that would be the same thing as saying, if I went ahead and wrote it out, it would be 1.23, and I'll just round to the hundredths place this time. Or I'll write out all the numbers there. 1.23088 times 10 to the negative 7th. And so that's what that number represents. And so when you look at that to the negative 7 there, that just represents the exponent. And it's the same thing as saying, in this calculator display, the E to the 16th power. And so in this calculator just couldn't express that exponent in the upper right-hand corner, so that's why it just wrote it in line with those digits. So here are some examples where we have to write the number in standard form. So it's the same thing we were doing with these calculator displays, and so we just take the number 7, which the decimal point's right at the end here, and then since it's at the end, we just add on 7 zeros. So 1, 2, 3, 4, 5, 6, 7, and then just add in those commas. On this one, it's a negative number, so it moves to the left. So it's got to go over one space to get on the other side of the 8. So that means I have two more zeros to add before I write the decimal point there. So these 2 zeros and then the 8 would give me that number. Here I just have to move the decimal 2 spaces to the right, Well, since the decimal's already at the end of the number, it's adding 2 zeros. Over here it's going to the left, but I need to get to the other side of the 2 first and then add on 1, 2, 3 more zeros, and that's 4 spaces over. So 3 zeros, then the 2 and the 7. And that would be the number. So here it's got to move again over to the other side of the 4, because it's a negative exponent, moves to the left, and then I have to add 4 zeros. So I got the decimal point, and then I add on the 1, 2, 3, 4 zeros, and then the 4 and the 4. So on this one, it moves to the right because it's a positive exponent. So I got to get to the other side of the 1 there. So I end up adding on an extra 2 zeros. And so I got on the other side of the 1 here, and then I add on the extra 2 zeros to make that number. So it's 2,100. So those are the types of problems that you're going to see on tonight's assignment. Good luck.